Hey, this is Tim DeStasio, and today we're going to talk about media filters, but we're not going to talk about it out here because this southern boy is cold. It's snowing out today. A popular and relatively inexpensive indoor air quality upgrade is to improve your filtration. Typical 1-inch air filters are about MERV 5 to MERV 8, and that gives you a relatively decent amount of filtration. But if you really want to step up your filtration to catch smaller particulates and catch more of them, then you want to upgrade your filtration to at least MERV 11, even 13 if possible. But there's a right way to go about doing it, and there's a wrong way. And that's what we're really going to talk about in this video, is how to properly upgrade and size and select your media filter upgrades. Every filter media kit manufacturer is going to provide some technical information to help you to size and select their product. For this video, I'm going to be using a Honeywell FC100 kit because this is what is readily available in my area. It's relatively inexpensive and it can fit a variety of applications. But there's more manufacturers out there than just Honeywell. Every OEM equipment manufacturer is also going to be able to provide their own filtration kit that fits their equipment. But the Honeywell is a universal. It can be retrofitted to existing equipment and installed with new equipment as well. So this chart here is going to give you all the sizes that kit comes in, and it's also going to give you some more technical information that's going to help you properly size that media filter. For the purpose of this video, we're really going to be concentrating on 3 factors when it comes to selecting media filters. First of all, what MERV rating are we trying to accomplish? And then at that MERV rating, what velocity do we need to stay under? And what pressure drop do we expect to have at that velocity? Now, it's important to understand that whenever a manufacturer of a filter media kit comes out with their MERV rating, they are testing that in a lab at a specific velocity. And if you exceed that velocity, then your MERV rating is actually going to go down. Think about it if you're trying to throw a tennis ball through a chain link fence. Your tennis ball represents a particulate matter in the air, and your chain link fence represents the filter. The faster you shoot that tennis ball at that chain link fence, the more likely it is for one of those tennis balls to get through the fence. And that explains what happens when we increase the velocity of air across a filter. At some point, some of those air particles can bust through that filter and get past it. So it's important that if we are selling a MERV 11 filter to our customer, that we're keeping that airflow below the design velocity that manufacturer tested that air filter at. If we don't, then we may be selling them a MERV 11, but it may be operating at MERV 8, MERV 7. We really don't know. The other factor is pressure drop. Obviously, pressure drop across a filter is very important, and a filter only stays clean for a very short period of time before it starts loading up. As it loads up, that pressure drop is going to increase, so we don't want to start off with a very high pressure drop. Notice here the specs on this filter. It is a MERV 11 filter, but it was tested at 500 feet per minute, and at that velocity, a clean filter dropped 0.23 inches water column. Well, that's pretty high for a pressure drop across a filter. When you think about trying to design a system for a 0.5 total static pressure and 0.23 of it's being used up by your filter alone, that doesn't leave a lot more pressure drop for your other devices like grills, registers, ductwork, dampers, turns and fittings, and the length of your duct. So we want to try to keep this pressure drop as low as possible, which means we may have to oversize this filter a little bit bigger than what even the manufacturer tells us will work. So let's consider some real life examples. The first example we'll consider is a 2-ton heat pump. Now this air handler here, we want to upgrade to a media filter kit, but we need to know what size. Well, this air handler, let's say, is roughly 16 by 20. Well, we may think that a 16 by 20 media filter would be the best fit because it properly fits that cabinet. But is it the best choice? Well, again, we want to check for 2 factors, the velocity and what the pressure drop will be. As you can see, according to the manufacturer's data, this 16 by 20 media filter actually has an opening of 14.5 or 14 7/16 of an inch by 18.25 inch. That's the opening that the air is going to be going through. So in this next slide, I've entered in my nominal CFM for a 2-ton unit as 800. I've also entered in my actual free area opening of the filter. Remember, this is a 16 by 20 filter that we're looking into using, but the opening isn't quite 16 by 20. It's a little bit smaller. So by using a duct calculator or an app that does the same thing, we can now determine what our velocity is going to be. As you can see from this next slide, our velocity is 465 feet per minute. Now, is that okay? Is that acceptable? Well, we have to look at our manufacturer's data to find that out. Again, we look at the Honeywell technical data that was available from the manufacturer. They test their filter at 500 feet per minute. So as long as we stay under 500, that's considered acceptable, and we should get the full MERV 13 performance out of that filter. The other thing we want to pay attention to is pressure drop. Now, they have a little curve here that helps us to line up our CFM, which is 800, according to that size filter, which is 16 by 20. Where our CFM meets that curve, we can draw a straight line over to the left and determine what our pressure drop will likely be using that filter, that CFM, and that's 0.1 inches water column, which is pretty low, and that's acceptable. So at 2 ton, this 16 by 20 filter is going to work just fine. Now let's say this is a 3-ton unit, not a 2-ton. Most manufacturers offer a 3-ton fan coil air handler in that rough size of 16 by 20 or 17 by 20, and we may be tempted to try to just bolt on a 16 by 20 media filter. But will that work at the airflow required for 3-ton? Let's find out. We're going to use the same process that we just used on the 2-ton unit. If we think we can use a 16 by 20 media filter, remember our free area is only 14 7/16 by 18.25. So we're going to plug those dimensions into our duct app, as well as our new airflow, which is the nominal 3-ton airflow of 1200 CFM. Ooh, looks like we have a problem here. Look at that velocity. It's almost 700 feet per minute. That's way higher than the test velocity of 500 that Honeywell rated their MERV 11 filter at. Not only that, but look at our pressure drop. If we line that up with a pressure curve, we're going to have a really high pressure drop across the system. That's going to result in a high total external static pressure, which could lead to other problems as well. The only thing we can do at this point is to increase the size of our filter to get our pressure drop and our velocity down. But the question is, which filter do we now select if 16 by 20 is not big enough? Well, I'm going to save you the suspense and show you how a 20 by 25 filter is going to work a lot better than a 16 by 20. Check out Honeywell's specs here. A 20 by 25 filter media kit, the rough opening is about 18.5 by 23.5. So we're going to use this same process and plug that into our duct app to see what our velocity is going to be. Check out our velocity. It's a lot lower. 435 feet per minute is acceptable according to Honeywell. We're going to get the full MERV 11 rating if we keep the velocity around that level. And our pressure drop is acceptable too at 0.1 inch. And you'll find that if you're first sizing your filter to not exceed that rated velocity according to the manufacturer, keeping that velocity well under 500 feet per minute, maybe even lower than 350 feet per minute, your pressure drop will take care of itself. But if you try to go the other way around and you size this filter according to the pressure drop, well, you're always going to size it for the high pressure drop of 0.23 in this case. Your velocity is going to be pretty high. You may not achieve that MERV rating. That's why I want to stress to you that you want to verify your velocity and make sure that it's not exceeding what the manufacturer's value is so that you get the full MERV rating out of that filter after you install it. So what effect could this have on your total installation? Well, when you upsize your filter, you've got to add a duct transition. So that's going to make your installed unit a lot longer. You've got to make sure that you have space for that. If you don't have space for it, then you've either got to make some duct modifications to create that space, or maybe you should rethink whether selling them an upgrade for their air filtration is really the right idea. If we add filtration, but at the same time we add a ton of duct static to a system that already maybe has a lot of duct static, is running a high external static pressure, we could be adding more problems than we're solving. So make sure that you're not doing that. Use some smooth duct transition, smooth out that airflow, and increase your size the right way. Everybody's seen this kind of setup, especially in houses with basements. A very skinny return drop that goes right into a media filter and then into a vertical furnace and coil. The problem with this setup is it's very restrictive. There's a lot of duct friction in that very skinny drop. The air also has to take a very sharp turn to get into the filter, and parts of that filter will see air velocity that will greatly exceed that 500 feet per minute. So it's better to do something different. Take this as an opportunity to improve some of their ducts. And that means maybe putting an elbow that goes up to a larger return drop that allows for better airflow, a little bit lower velocity, and a little bit less turbulence. So take these opportunities, if you're going to upgrade them to a media filter, to also improve some of the other accessible duct sections so that you can increase your performance, decrease your duct static pressure. You may even have to relocate that filter so that you can make it bigger, maybe putting it in the vertical drop and having a transition that steps out bigger to accommodate the size of the duct. Don't be afraid to think outside the box and maybe relocate that filter so that you can get the full use out of it. What if your air handler is moving so much air, for example a 4 or even a 5-ton air handler, that one single filter, according to your calculations, is going to have too high a velocity, too high of a pressure drop? What are your options then? Well, you might be able to do something like this, where you add a second filter and you divide that air across 2 openings. This way, again, your velocity across each filter is a lot lower. Your pressure drop is lower because you're dividing that total airflow across 2 filters instead of just 1. Or you may be able to select a different filter manufacturer that makes a larger filter that will accommodate your needs. Don't be afraid to change your allegiance if your manufacturer of choice isn't making what you need it to make. If they're not doing it for you, then you've got a customer to satisfy. You've got airflow requirements. Make sure that you're putting something in that's going to work. Don't just put it in because that's what's available. I created a chart for the Honeywell filters because that's what I use the most of. And for each size filter and each available tonnage from 1.5 all the way to 5, I'm calculating what my velocities will be. And that helps me to rule out what filters I definitely don't want to use, and it helps me see what my options are. For example, if I'm working on a 4-ton unit, I know that there is no option for a single filter that I can use that keeps my velocity under 500 feet per minute. I have to go with 2 filters. But what size filters? Can I go with 2 smaller filters to save them a little bit of money, maybe save some space? Well, this chart helps me to figure all that out. So don't be afraid to make your own chart. If you have a filter of choice that you like using, look at the manufacturer's data. Maybe they've given you a chart already. This one's a quick cheat sheet for me so that when I go price these jobs, I know exactly what to price them right there on the spot without having to go back to the office and make calculations. So whatever your manufacturer of choice is for a media filter upgrade, that part really doesn't matter. They all perform pretty similar to one another. The main thing you want to do is make sure you properly select, size, and design your system to work around that media filter. If you're upgrading an existing system, you may have to make some duct modifications. If you're installing a new system and this system is going to have an upgraded media filter from the start, you want to make sure that you design the entire system, even the rest of your ductwork, around that pressure drop. Pay attention to your velocity. Pay attention to your pressure drop, keep those well under what the manufacturer recommends them to be, and your customer will enjoy a lot cleaner air, and they'll get the full use, the full performance out of that media filter upgrade.